Well, we can attempt to look at this thing about conservation of momentum. Now, when you have something that is spinning, and you have momentum. Now, if you rotate that momentum or change the direction of the momentum, it's just, what's it got to do with conservation? I'm not too sure. So you bend this spin plane and you get gyroscopic precession. Now, is that some kind of conservation of momentum? I'll just leave that as a question in light of many other phenomenal features of gyroscopes. But okay, one way of looking at this is that we have a wheel that is just a wheel. Now, and let's say it's spinning in this direction. Right now, you bend the plane of that. Now it starts to precess. So this is the plane of the static wheel, the pink. Then the white here is the rotated position. Now, when you rotate this, you do change the points. These points that are traveling here do get closer to a fulcrum. And these points out here are further away from that fulcrum. So now what happens? This spins around this arc closer to the fulcrum a little further than this point spins around a bigger circle. So what that means is that you have a distance traveled by the, let's say, just call it the upper points as they are traveling along. And then on the lower points, you have a lesser distance because they are traveling on a bigger arc. Now, that has to mean that you're going to have a translation of the rotated wheel versus the so-called vertical wheel. Because this point is traveling further, so it drags the center from here to here. Now, what's that? Is that a better explanation than conservation of momentum? I have certain worries about this presentation, but basically you have longer versus shorter versus the vertical, and they are different arcs, and so the wheel has to move. So that's precession in our view.